Hey folks, this video lesson should cover naming and writing with transition metals.
Hey everybody, it's me. This is my little lecture on naming with transition metals. This little tutorial will take you through how to name ionic compounds with transition metals. In addition, we'll do naming ionic compounds writing the formulas given the name. So pay attention, listen closely. You all know that naming ionics, very basic ionics, you just use a metal and a non-metal, and the same rules apply. The metal keeps its name, the non-metal drops the ending and adds IDE. Here's the thing about transition metals that's so tricky. Both of these substances are possible compounds that iron makes with oxygen. The first one is called iron oxide, and the second one is called iron oxide. So the question is, how do we tell the two apart? Now normally you would think you would tell me how many irons there are in each compound. That's what would make sense. But this is not going to make sense to some of you because it's not that easy. In the same way that we identify isotopes of the same substance by their different masses, we are going to identify these different compounds of iron oxide based on not the mass, but the charge on the cation. In other words, what you need to do is take a look at what the charge is on the iron in each of these, and we're going to then use Roman numerals right behind the iron in parentheses to tell me what the charge is on each iron. And so, let's begin with iron FeO oxide, and the other one is Fe2O3 iron oxide. The one on the left. If you look at the non-metal, and this is true of all nonmetals, you always know the nonmetal's charge. It never changes. Metals have a tendency to change, especially if they're transition metals. Not that the charges change, but that ions could have potentially 2 or 3 or 4 possible charge options, like these. You've got one with one charge on the left and the one with another charge on the right. So what you do is you take a close look at the anion's charge. In green, I will put the charge of iron as -2. That's the case for both sides. Now on the left side, right here, iron's charge must be the same but opposite sign of that of oxygen. And if there's only one oxygen, then that must mean that this iron is a +2 charge. So when I go up and put the charge in Roman numerals behind iron, the name of this compound is called iron 2 oxide. Now, looking at this one on the right, because we know that the charge on the oxygen is -2, and it will not change, it never really changes, it's always -2, because there's 3 times -2, that means that there's a total of -6 on this side. Now, I have 2 irons. What must the charge be in order to get the same number, opposite charge, as -6? Well, 2 times 3 is +6. So X must be, or in this case the charge on the iron, must be a 3, because 2 times 3 is +6, and 3 times 2 is -6. So yes, 3 times 2 is -6. 2 times 3 is +6. So, that means that the charge on the iron is +3. And now when I go back up, I put Roman numeral 3, and these are 2 completely different substances. This iron oxide on the left is black and magnetic. This iron oxide on the right is red and not magnetic. These are 2 completely different substances. Now let's take a look at another example. I want to make another page. Let's say you're looking at copper with chlorine and copper with chlorine. Both of these are copper chloride. Both of them are copper chloride, as I just mentioned, but they have different charges on the copper. Now, taking a close look at the anion, each chlorine comes with a -1 charge. So if this is a -1, that must mean that this copper on the left must be +1. We put Roman numeral 1. Copper on the right must have a +2 charge because you've got two -1 charges for the chlorine, so there must be one +2 charge for the copper. This is another example of a transition metal that could potentially have more than one charge. And my last example here is going to have lead, PbCl4. Now this is lead chloride. But now I go back and check the charge. The charge on chlorine is still -1, and there are 4 of them. So on this side, I have an overall -4 charge overall. Now on this side, I need there to be a +4 charge, but I've only got 1 lead, so that must mean that 1 lead is a +4 charge. Now I mentioned in class that you probably won't have charges larger than 3 or less than -3, but this is a strange case where lead, because it's a transition metal, can actually form a +4 charge. And Roman numeral 4 is IV. VI would be 6. 6, not cis. So when you're naming transition metals, you have to make sure to include the charge behind the name of the metal in order to get the right name. Now what happens if you actually have the name and you're trying to write the formula? Well, I think this is kind of easy. Take, for example, tin 2 oxide. You do the same thing as you would if you were naming normal ionic substances. When you name normal ionic substances, you write out the charges of each. Well, you don't have to go looking on the periodic table for tin's charge. It's right here in the Roman numeral. You do have to go and look on the periodic table for oxygen. Basically, or because we worked with it so much, everybody knows oxygen's a -2. So tin, which is SN, that's a +2 charge. Oxygen's a -2 charge, and just like we did before, you could balance out the 2 +2 and -2, and that means that the formula for tin 2 oxide is SNO. That's the answer. Do it again for things like iron. That's not iron. This is iron. Iron 3 nitride. Iron 3 nitride, that'd be iron with a +3, nitride with a -3, that's one of each, FeN. Last example, let's do copper 1 selenide. Copper is the +1 charge. Selenide refers to selenium, which is a -2 charge. So, well, I've got a -2 on this side and a +1 on this side. I need 2 times the +1 to make +2. So when I translate that, it's copper with Cu2Se, and that's my final answer. So that's naming ionic with transition metals.
That takes care of this video lesson. Thanks for listening.